My name is Grant McWilliams. I'm a teacher. I teach computer science, but I also have a consulting company. So basically most of my time is spent doing product development, making products for companies, and then I tell people I'm a college professor because that's a respectable job and it's easier to understand. If I tell them I'm a custom product developer and they say, well, what do you make? It might be different things at different times. It might be the in-flight entertainment system in the airplane you flew in on. It might be something completely different. And to quantify that so people understand it is very difficult sometimes. So, I teach. But the reality is I teach part-time. Now, the reason I kind of wanted you guys up here, and you don't have to come up here, is that I like having interactive sessions. Is if you guys have questions in the middle of it, you can ask me questions and then I can respond to them. You can ask them back there too. We'll work it out. Okay, so I've been around Zen for a while. I'm active in the online forum, the wiki. There's a bunch of my stuff up on the wiki. I started a project called XAPI admin project about 2 years ago now to document the XE command with Xenserver. The XE command has 431 sub-commands, none of which have a man page except for I think the main one. And so what this is a group of about 10 people, and they're actively working on making man pages for the XE command. And so they're like 150, 200 into this thing. It's a massive project. We're going to try to get it pushed over into to have it being auto-generated whenever you create Xenserver. We're not anywhere near there, but that's really the plan. I also manage Zen Cloud Platform / Xenserver Google Community. Now it's invite. You have to go click on the button and say, we want to join this. But we have quite a few moderators, and they'll let you in pretty quick. The reason we did it moderated is because these things, Google communities, they like to turn into basically advertising communities very quickly. And so we didn't want that to happen. So there's about 350 people in there. It's fairly active. It's unofficial, by the way. But a lot of the same people you'll see in other forums are here, and they answer questions and so on. Anyway, I like it. So, the Zen API.
Do you want help making it somewhat official?
What's that?
Do you want help making it somewhat official?
Hey, you know, I made that suggestion about a year ago at the Zen Summit last year in New Orleans, and I have no problem making it official. I have no problem even having someone else take care of it.
Well, I don't know if I'd volunteer that aspect. But we should talk.
Yeah. Because, you know, it's unofficial right now just because I started the thing and everyone else started using it, and that's fine. And I don't have a problem managing it. I basically answer questions every once in a while, let people in, and keep the thing going. And there's some other folks there that do that as well. So the Zen API admin project is, again, is documenting the XE command. And this is a revolving number of people that join it. Mostly my students. I like to give them projects in the open source. And then I have some other projects I'm involved in that may or may not be that interesting, but they're Zen-based. In my classes, I use a virtual classroom using Xenserver. It started out as XAPI, and so there's this thing called saltstack, and it's basically this tool that I use to manage software or manage virtual machines based on classes. I pull in a roster, it goes on if it creates the virtual machines. If I need to reboot them, I need to wipe them. Students mess them up a lot, and I'll just hit a button and say wipe, and it wipes the virtual machine, pops up a new one, and we're good to go again. Although if another tool, looking at these guys over in the corner, if another tool does this for me, I'd stop developing this. Took care of everything, multi-tenancy, students could take care of it themselves, and I wouldn't have to manage this anymore. But if someone wants to use this code, it's there. All right. So, the product I'm going to be telling you about today, this is not the actual name of the company. I'll talk about that in a second. But this presentation, building a massively scaled Xenserver-based security appliance. We already covered that. I'm going to have another slide at the end that tells you how to get a hold of me. About my company. My company's been in business for 23 years. Obviously, it wasn't sound Linux training 23 years ago. I did a lot of other things. It was all computer consulting. But in the last 10 years, maybe 14 years, it's been 100% either Linux or open source. And that basically 100% of my money at this point in time My income comes from Linux and open source. We do product development. Disclaimers, no animals were harmed in creating these slides. That was supposed to be at the end. To protect the identity of my client, I had to come up with a pseudonym for the project. It's kind of an interesting story. Last year, I'm not supposed to tell you that either. Anyway, last year I did a presentation and everybody was, they liked it. And I get back to work and they said, hey, we'd like to have everything go through the marketing department first. I was like, well, I was doing free marketing. And I said, so take all the interesting stuff out of there. So what we've done is I've created a pseudonym for this company. It's the fictitious Cyber Guardian 3000, okay? Just imagine an echo chamber or something in there. This company, keep in mind it's a real company, but not with this name, is an IT audit and security compliance company, which means they hack other people's networks and they get paid for it. It's a really cool job to have. They're doing it for the purpose of making the other network more secure, of course. And they get paid for it. So this product that I've developed for them, they had some criteria for me. It had to be easy to ship, so it had to be relatively small. It had to have a one-button interface, which changes your development a lot in that you don't have a way of interacting with the device. The customer sees a power button. That's the only thing they can do is they can plug it in, turn the power on. If they want to move it somewhere, they just hit the button, shuts it down, moves it somewhere else. Just like, say, a Roku or any of those other types of devices that you have. It had to have no moving parts. Okay. Had to support multiple security products like scan services, penetration testing, database testing, and so on. So far, everything's easy, right? Had to be cheap so it can be bundled with a service. So the cost of each device had to be low. Again, we're looking at relatively simple technologies here. Number 6, had to be able to run more than one operating system on the fly. And number 7, had to allow multiple overlapping network segments. So the last two make the project an interesting project. And that basically means that we're going to run some sort of a hypervisor on here. And we have a small hardware platform. We have a limited amount of RAM. We have a limited amount of hard drive space. And we're going to put the hypervisor on it. The purpose of this device, of course, is PCI compliance, HIPAA, and there's some other certifications that companies have to get. In some states, if you process more than a certain number of credit cards, let's say 30,000 credit cards a month, you have to be PCI compliant. You have to pass compliance every year to show that you're secure. So we have a business of people that just need this. A lot of times it's a mom and pop shop that doesn't really know anything about security. Sometimes they're big companies. And what we do is we take this box and we drop it into the customer network. The device opens up a VPN connection back to us, and then either through an automated service for scans or through an interactive service where a security professional would actually log in and do penetration testing. They come back in through the network and they scan the internal network, they try to find vulnerabilities, things that need to be fixed, and so on. Okay, and then the customer logs into their portal and they get a report saying which things are broken, which things aren't broken, and so on. Okay, so the deployment scale, what they initially wanted from me was hundreds of physical machines, thousands of virtual machines, and then we're going to build a cloud version of it that would go out there into Amazon and so on, and there'd be an infinite number of cloud machines out there. We're sitting at about 700 physical machines for the year, and so you're looking at about 2,000 virtual machines at this point, and they're wanting to scale it up drastically from there. So we have various sizes of devices here. We chose Xenserver. Now, putting a hypervisor on a box, we could have used anything. We could have used VMware. We could have used straight Xenserver. For this size of a box, we probably could have used VirtualBox. It's going to run maybe a maximum of 3 virtual machines. What we needed is the ability to interact with the hypervisor easily. And the Xen API is a very nice API to work with, in my opinion. It gives you a lot of control. It's easy to integrate into your products. So we basically chose Xenserver, what was at the time Xen Cloud Platform, basically because of the API. Okay, so it's free and open source. The great documentation, thanks to Citrix. I put a plug in there for the XenAPI admin project. They're slowly adding more and more stuff. And the Xen project community is actually pretty cool. I just added that line earlier when I was listening to some of the other folks talking up here. And it actually really is true. You can go out there and ask a question. You get treated nice, and so on. Okay, so advantage of using Xenserver as virtual machines on a single OS. We can have multiple products on one physical device. So if you imagine we have one physical machine, a company has subscribed to it, they get this machine in their network, and then first it starts out with scan services. So they say, we want you to scan our network and find vulnerabilities. And then later, they come back and say, well, we'd like to have penetration testing services, or we're rolling out a big database, and we'd like you to test the database and make sure it's secure. The box is already there. And so it would be nice to be able to just spool up some sort of a tool to do those additional services. Okay. Now, if that was a Linux tool, we wouldn't be doing a hypervisor, would we? Because we just have one Linux box in there that would just did everything. But the problem is some of those tools that they want to use are either Windows-based, or maybe it's a Kali Linux-based system, and so on. So we needed this ability to have two products. The product that I'm talking about here is virtualized hypervisor system, and then we have a second product that runs on it. And that product would be a scan engine, maybe a second product or a third product would be a penetration testing engine, database engine, or even things that we haven't thought about yet. Having this sort of a system, we could just add services and products depending on what we came up with. Okay? Issues with Xenserver in this role. Xenserver wasn't designed to do this kind of thing. Xenserver was designed to virtualize servers and so on, infrastructure. So a headless appliance with a big power button just begging to be pushed while VMs are running results in havoc. You know someone's going to go up there and either just pull the power cord when all the virtual machines are running, or they're going to go up and push the button because we only gave them one interface. Gave them one button to push, that's the button they're going to push. So we needed to basically harden the thing so that way it could survive downtime. In a previous life, I did in-flight entertainment. Those systems were very similar. The flight crew would walk over to the crew panel and flip the switch, and you'd have 600 Linux machines just die. And then turn the switch back on, and all of them would boot back up again. And they had to survive this over and over and over again. So I took a lot of those same tactics and I put it into Xenserver and tried to make the thing survive basically just hard shutdowns, okay, with virtual machines running. So no disk encryption by default, so customers' data could be accessible if the device went wandering. We've made a small machine that's easy to carry, that looks really cool, that would make a nice home media center. So we're worried about these machines being out in the customer network, someone deciding, hey, that's pretty cool, I don't think we're using it, and just taking it home. Or maybe it gets lost in transit, maybe we're shipping a box back. So we had to make sure that the data on the disk was secure and that people couldn't get access to it. Okay, so not designed to be run on small platforms with limited disk and memory footprints. We had to think about that, how much memory we were using. If we're not going to run 3 virtual machines at the same time when we have a couple gigs of RAM, right? We're going to be bringing one up. If you want to do another service, that one has to come down. The second one needs to go up. We need a system for managing all of that. The disk hits were pretty bad, so we had to think about what we could do to optimize the disk as well. We're dealing with 2 cores and a limited amount of CPU power. Okay, so no real secure remote access for the control domain itself, as opposed to forwarding encrypted traffic to a VM. From the VM, we'd have a virtual private network coming out of there. We're not worried about that traffic, but we need to be able to interact with the hypervisor itself, so we needed a way of dealing with that as well. Not really designed to be quick provisioned, okay? So Xenserver doesn't have a lot of flexibility. Now, the talk that we just saw about where Xenserver is going in the future, had that happened before I started this, I would have done it completely different. But with Xenserver, we basically pixie boot the machine. It comes up, does a standard install, and then we hit it with some customized provisioning that turns it into what we want. And it wasn't ideal. Now, if we just had a straight sent to us machine, and we could provision it any number of other ways, and then use a provisioning system, that process would have been a lot different. So we'll talk more about that in a minute. Okay. Number 6, Xenserver really isn't that silent on the wire. So if you think about a secure network, you have a Xenserver machine sitting in the network, and you're trying to scan the network to see where the vulnerabilities are. You don't want your system adding traffic to the network, because then you're going to be pulling up this information that's actually your system itself. And so we had to do some things to make Xenserver much more quiet. Okay, network overview looks something like this. Now, one of the requirements were we would have to have overlapping networks. So let's say we had client A has their entire infrastructure on 192.168.0/24. And then we have another client that we pick up, another customer, and their network is exactly the same network, 192.168.0.0/24. Now we have two different ones, VPNs connected to them, same IP addresses. We have to worry about this. If we put our network on the exact same one, then one of our IP addresses for our banking servers might clobber one of our customers' servers. This is real, this happens. So we needed to come up with a different way where we had network space that didn't overlap, and we translated. So it ends up being kind of a double NAT system. Okay. The physical platform overview looks like this. You've got a box, we have a VPN going back out into our network, and then we have whatever virtual machine that we need. We're using Kali, CentOS at this current time. In the future, maybe there'll be some Windows in there. And that's what connects into the customer network and actually does the work. It needs to be able to offload that data back to us, but outside of that, their traffic doesn't come back. Okay, so we can keep them somewhat segmented. Okay. Another request was a virtual platform. So what I'm just showing you is actually a physical box that we build, and then the virtual platform would be if someone else has a VMware infrastructure, Hyper-V, standard stock Xen, open source Xen, any of that stuff would be separate, and we would want to provision into that environment as well, without the physical machine. Cloud looks a lot the same, but we're dealing with AWS, Verizon, Azure, and some of those guys. And we've provisioned into all of those. So the disk solution is kind of interesting. The stock Xenserver disk layout looks like the bar above. We have root file system, TMP, var, and swap all in one partition. The swap really bothered me because we're swapping into the disk where the rest of the operating system was. You go up and you push that button, and we're swapping in there, and it's going into the same same partition into a swap file. We're probably going to invalidate the hard drive a lot. Okay, so that had to be fixed. The next block is space reserved for upgrades. That's what's basically saved me, because now there's a big space on the disk that I could use for other things. And then the way they have it set up by default, you have a storage repository for the rest of it, and it's using thin provisioning for snapshots. So it's using an LVM type for that. So what we did is we took the root file system and we made it virtually read-only. There's only about 4 files I get written to in there, and they're very, very minor. I could have gone that last little bit, made the whole thing read-only. I don't think I would have really gained a lot, and I would have spent a lot of time on it. Okay, so then the var partition, we have a var partition, and it's encrypted. We have an external USB key that has the cipher on it, and it knows to go to look there. And then we have a duplicate of that partition, basically a golden image. So the var2 there is a golden image. It's a var that works. The first one is going to be writable, and we're going to be writing to that. We're going to log to it and stuff like that. So the chances of it getting messed up are possible if someone goes up and pushes that button. So if that happens and the system goes down, when it comes back up, it checks the consistency of the var partition to see if it's okay, and if it's not, it just takes the golden image and writes back over it again. And we've done this in the in-flight entertainment industry because that's basically what had to happen. We didn't have a lot of CPU power and a lot of other disk network or disk resources that we could use. The swap partition is now encrypted, and the storage repository we changed over to an ext storage repository, so we had thin provisioning for disks. So across the virtual machines, we're now saving a lot of space. If we have 2 with a very similar base, we thin provision the disks, we bring them up, and then we just configure the differences, and we're saving a lot of disk space. Okay, and then TMP is now sitting in RAM. Questions yet? Okay. Now, had we not been using a stock Xenserver system, let's say we just had a stock CentOS system and brought it up, we could have built this however we wanted to. We wouldn't have had to try to, you notice the two var partitions are sitting in that reserve space where the upgrades go. We actually took over that, so obviously we can't upgrade the Xenserver system the traditional way, but if I had the ability to use a stock CentOS machine a year ago, all of the development that we've talked about now would have been completely different. Okay, so OpenVPN Community Edition is what we're using. I wrote some software called VPN Magic, and it basically handles the double NATs. We can move the back end, we can move the front end on the fly. So if for some reason we needed to remap the whole back end server architecture, we could say we'd write into one file, restart the service, and all of the back end changes. The front end, if we have a clash with a network in the client network, and we get a new client and they have the same network, we can just decide to put those on a completely different segment, and there's no more clashes anymore. It works with OpenVPN Access Server, it's a commercial product, and it also works with the Community Edition, but it doesn't have the double NAT support for the Access Server. There's some limitations in the commercial implementation. It also allows load balancing for the VPN connections. So it comes in, every new connection it sends to a new VPN server. Because again, we're gonna have maybe 10,000 of these machines, and they're gonna be coming into VPN servers. And we're gonna see how that works because we're virtualizing the VPN servers and we don't have a hardware AES. So we're gonna see how many we can run before we really start bringing some infrastructure down. Okay, saltstack remote execution. You guys know what saltstack is? Anyone use saltstack? Okay. It's configuration management like Puppet, like Chef, CF Engine, the ones that came before it, Ansible. Saltstack is really pretty cool. We moved about midstream from Puppet to Chef, or I'm sorry, Puppet to saltstack because of scaling issues. And you can scale Puppet. You have to start replacing some stuff, use a different web server, use a different, and so on. We got partway through that and said, why are we doing this when we have another system out there that's very, very good? It gives us remote execution along with configuration management. And so far it's been pretty good. I've had some issues with it. What they call minions, the device that you control, like to time out. And since it's like this continuous communication, if they time out, then your end just doesn't tell you anything. And that's probably my only real gripe with it. And sometimes the writing the configurations can get a little bit odd. Okay, so saltstack is very light, excellent scalability, remote execution built in, and we have minions. You gotta like anything that has minions. Logging and monitoring is done with Zabbix and rsyslog remote logging. And again, the idea is that we're trying to pull the stuff off the box as fast as possible. We don't want to leave it out there. So whenever we do a scan, that data comes back immediately across the wire. We don't save it on the local disk. We had to put in some sort of a monitoring system to keep an eye on what all these boxes are doing. We looked at a bunch, and we kind of settled on Zabbix because it worked, and it was relatively easy to put together. And we'll see if it handles the load. But I'd be interested too if you guys want to come up after and tell me what your solutions are to similar problems. But something like this, you don't know it doesn't work until you've actually deployed it. And you run it out to several thousand, and then it doesn't work anymore, and you have to find a new solution. So the rsyslog is pulling all the logs off, basically audit logs, messages, secure, and a few others. And it pulls those off, and we have them in a central location. So in case we actually lose contact with the box, remember that we don't have an interface to this. We can't see it. So if the network goes down, we can't even tell the customer what's wrong with it because we can't see it anymore. So all of that data has to be pulled out while the machine is running. Okay, so provisioning goes something like this. Xenserver PXE install. We'll see if there's development funds available to change this when Credence is out, because then we could build the CentOS system in a more traditional manner. Or even use Kickstart. We could use a million different ways of building it. If not, the system is working. Remember, do custom software creates Salt, VPN, and other configuration. This is software that we wrote. Salt SSH creates custom Xenserver ruggedized disk layout that we covered earlier. Basically moves a bunch of stuff around, makes the new mount points, copies the data that's necessary into those places, and then reboots the system. And the system comes back up, and we hit it again with salt SSH. Salt SSH doesn't require an agent on the box. We can just use a SSH to send commands across, and it's all within the salt configuration management system. And then it finishes it. So it provides a VPN magic configuration for the box, sets up everything so they're all unique, and then creates the base images for the virtual machine. So we have the hypervisor machine, and then we have the base images for the virtual machine. So we'd have a base Kali OS VM, and maybe we'd have a base CentOS machine, and in the future, if they needed, a base Windows machine, and so on. It builds those, and then we use SaltVert to clone the base images and boot them up, and the product is running. Okay. So depending on what they've signed up for, we build it into just a scan engine or penetration testing engine, and so on. Okay. So provisioning the virtual appliance right now isn't quite the same. Now, a lot of these companies have really neat ways of provisioning the software, but everyone does it differently. The cloud software, you get into that too. Amazon has Cloud init. That's awesome. But then we go to another provider and they don't. So then we have to have another different system. So we tried making the provisioning the same no matter what provider we rolled it out on. So currently for a virtual appliance, we ask the customer, build us a Debian Wheezy VM. Just pop it up there, give us a Debian Wheezy VM, and we can get into it, and then we'll finish it off. So then our software creates the VPN magic configuration again. Salt provisions a virtual machine to a scan engine, a penetration testing engine, or whatever they've asked for. And then the VM connects back to our company, and the same, from there on out, it's all the same. We're probably going to make that a more streamlined process in the future. The cloud appliance, again, is not using Xen, it's using a cloud instance like AWS or Azure or something like that. So Salt Cloud provision the base image. That keeps it roughly the same depending on the cloud provider. Our software creates local VPN magic configuration again, and then Salt provisions the virtual machine for its final role. So you see that only number one is changing, how we actually bring the box up and get it live before we turn it into the product that we want. The rest of it stays the same. Okay, so the future, base the hypervisor platform on CentOS 6 or 7. This is basically where Credence comes in. We would build the CentOS box, and then we would turn it into what we'd consider, Xenserver, install the appropriate packages, and then build it up from there. And that gives us a lot of flexibility that we just didn't have a year ago. And I was watching as I was developing this product, I was watching the process of Xen Cloud Platform or Xenserver in RPMs, waiting and hoping that it would come along before we would get to that part. And it just didn't, so we did it the way we did. So that changes the entire provisioning process to standard practices with Kickstart and Pre-Seed or whatever we decide to build the platform off of. Are there any questions? No questions? You can get a hold of me here, my website. I have a Google Plus account, of course. Twitter. I don't follow the Twitter as much as I do with the Google Plus. I have email addresses on there. XenaPIadminproject.com is there. Any suggestions? For those of you that have run systems where there was a lot, massive, let's say monitoring or logging, what have you used? Okay. All right. Well, that's all I have for you if you have no questions.